Okay, so Unit 2, Topic 3 was rational functions. Write an equation for each graph. So hopefully you know what the parent function of 1 over x looks like. If not, definitely take a minute and look that up. So for A, our graph moved left 2 and down 1. So left 2 and down 1. Now for B, I noticed that the asymptotes are still at 0, but what's different is this point is at a height of 2, meaning it's been vertically stretched. But the graph's also been reflected, so we're going to make the numerator negative. So the first thing we want to do when we start graphing is graph our asymptotes. So for A, we have a vertical asymptote at x equals 1, and a horizontal asymptote at y equals 3. And then to get our other accurate points, I like to pick a point to the right of the asymptote and a point to the left. And when you plug in 2, you're going to get a y value of 4. When you plug in 0, you're going to get a y value of 2. And then I know this piece approaches the asymptotes up here, and this piece approaches the asymptotes on the bottom. Do the same thing for B. We have a vertical asymptote at x equals 3, and a horizontal asymptote at y equals negative 2. Pick a point to the right and a point to the left. So when you plug in 4, you get negative 1. And when you plug in 2, you get negative 3. So we get 4, negative 1, 2, negative 3, and approach your asymptotes. Do the same thing on my left part, and there's our graph. Okay, for the least common multiple of the denominator, for A, one denominator is x minus 3, and the other denominator is x plus 2. You can only multiply when you make common denominators, so our least common denominator is going to be x minus 3 times x plus 2. To solve, in A, you can cross multiply because you have one rational equal to the other. You could also make a common denominator, but I'll do the common denominator for part B. Okay, we're going to distribute. Move your like terms together. And when we get x is negative 29 over 2. To check to see if it's extraneous, you look in the denominator, and we need to think, well, negative 29 over 2, will that make any denominator 0? And in this case, it will not. Negative 29 over 2 minus 3 and negative 29 over 2 plus 2, neither of those equals 0, so it's not extraneous. Now for B, our least common denominator is going to be x plus 2 times x minus 2. And to solve on the right, well, you have a few options. We can make a common denominator with the equation on the left, and I'm going to do it that way since that's what I said I would do before. But I noticed the numerator on this side factors, and then one of my terms will cancel, but that's okay. I'll just go with the common denominator. So once your denominators are equal, you can equate your numerators. So I'm going to multiply. I'm going to move everything to the right so I can factor. And I get x equals negative 2 and x equals 2. But we have to check to see if they're extraneous. No, they both are. If you take 2 and plug it into your denominator, you get 0. And if you take -2 and plug it into your denominator, you get 0. So there are no solutions. I have to do it the factoring way. It's bothering me. Okay. You could also factor the 3x plus 6. You can factor out a 3. And eliminate that term. So you would have 3 over x minus 2 equals x plus 1 over x minus 2. And now that my denominators are equal, I can say 3 equals x plus 1. And when you solve it, you get x equals 2, which is still extraneous because it makes that denominator 0. You could have picked either way. All right, and now on to 4. We've got, this is our 1 over x, this is 1 over x squared. Even symmetry is y-axis, so g of x has even. Odd symmetry is origin, so that is 1 over x. For the domain for 1 over x is all real numbers except 0. So I'm going to write that, say all real numbers, x can't equal 0. It's the same domain for g of x. Another notation you can write is -infinity to 0 and then 0 to infinity, not including 0 each time in your interval notation. But these two domain notations mean the same thing. You can pick whatever one you like if it's free response. For the range, for the f of x, it's all real numbers except y is not 0. But the range for g of x is everything is greater than 0. End behavior, so as x goes to -infinity, our y is approaching 0. And as we go x into infinity, our graph is approaching 0. It's going to be the same end behaviors for g of x. As x goes to -infinity, our graph approaches 0, actually on both sides. Okay, so for 5a, how long will it take the one painter? Well, if it's a 4,500 square feet and he can do 300 in an hour, that is going to equal 15 hours. Since we divided to find that constant, they are inversely related. To write our equation, so the number of hours it takes is going to be 15 divided by the number of, n is the number of painters. So if we have 4 painters, 15 divided by 4 is 3.75 hours. An equation of directly related would be, let's say your pay per hour. If you get paid $10 per hour and you work for 5 hours, how much do you get paid? So 10 times 5 is your directly. And now for 6, write an equation. Okay, inversely, so H is 200 over S. Show that these equations are equivalent. So we have to do some long division with g of x. So to do this long division, 2x divided by x is 2. And then you're going to multiply it back by each piece of x plus 3 and subtract. So we can rewrite that as 2 plus the remainder over the denominator, which is the same thing as f of x. What are the asymptotes? So we have a horizontal asymptote at y equals 2 and a vertical asymptote at x equals -3. Okay, I'm going to do the same thing for 8. Five x divided by x is 5. Multiply it back. Subtract. We have a remainder of -1. So that is 5. You could say plus -1 over x minus 4. That is the same thing as minus 1 over x minus 4. And we have our asymptotes. Okay, so if she bakes 10-pound cakes, plug 10 in for x. Use your calculator to evaluate that. And you should get $31. And if it costs her 11, we're going to plug that in for C. And solve, so we're going to multiply x to the left. Subtract the 6x. And divide by 5. That is 31 cakes. Pound of cake. Oh, pound cakes. That's a type of cake. All right, so 31 cakes. All right, we'll do the same thing for 10. If she makes 22 fruit cakes, that is our x. And simplify that. We get $33.80. If she makes $18.75. Okay, so when we solve this and we multiply the right by x minus 2, you have to distribute the $18.75 to both of those. And then I'm going to move my x's to the left, move my numbers to the right, divide, and you get 50 fruitcakes.